Hello and welcome to our channel. Today, we are going to talk about Booth's algorithm, a multiplication algorithm that is commonly used in computer hardware and software. Let's start by reviewing how multiplication works. When we multiply two numbers, we typically use the distributive property to break one of the numbers down into its digits and then add up the resulting products. For example, if we want to multiply 23 by 5, we can write it as 23 by 5 equals 20 plus 3, x5 equals 100 plus 15 equals 115. However, this method can be slow and inefficient when working with large numbers. That's where Booth's algorithm comes in. Booth's algorithm is an algorithm for multiplying binary numbers that is designed to reduce the number of additions required. The algorithm works by considering pairs of adjacent bits in the two numbers being multiplied. If the two bits are the same, we don't need to do anything. If the two bits are different, we add or subtract one of the numbers depending on the value of the other bit. Let's see how this works in practice. Suppose we want to multiply 1011, 11 in binary, by 1001, 9 in binary, using Booth's algorithm. We can start by writing out the numbers in binary and aligning them. 1011, 11, x 1001, 9. Next, we can add an extra bit to the left of the first bit of the first number and initialize it to 0. This is called the auxiliary bit and is used to handle the case where the first bit of the first number is 1. 0 1 0 1 1, 11 with auxiliary bit x 1001, 9. Now, we can start the algorithm by looking at the first two bits of the first number and the first bit of the second number. 0 1 0 1 1, 11 with auxiliary bit x 1001, 9 0 0 0 0 0. Since the first two bits of the first number are 0 1 and the first bit of the second number is 1, we subtract the second number from the first number. 0 1 0 1 1, 11 with auxiliary bit x 1001, 9 0 0 0 0 0, subtract. Next, we shift the first number and the auxiliary bit to the right by 1 bit. 0 1 0 1 1, 11 with auxiliary bit x 1001, 9 0 0 0 0 0. 0 1 0 1 1, shift right. We repeat this process for each pair of adjacent bits until. That's it for today's video. If you found this video helpful, please don't forget to like and subscribe to our channel for more videos like this one. Thanks for watching.